Okay, so in this video we are going to learn Schmitt Trigger circuit. If you see carefully in the circuit, you will see that it's a positive feedback circuit. That is, we are taking the feedback voltage from output to the non-inverting terminal, right? So it's a positive feedback circuit. So in this video we are going to change EI. We are going to vary this EI voltage, and then we will we will obtain a output versus input voltage graph, and we will obtain a hysteresis graph in this video. So let's start. So first, let's say initially when we are going to start our this thing initially, let's say we have said input voltage is greater than 0, and if this so, the non-inverting terminal voltage, let's say it's B prime will be greater than 0. Okay, and if the B prime is greater than inverting terminal voltage, that is 0 volt, then we will say that output voltage is equal to positive Vset. So what is positive Vset? I haven't drawn this in this circuit, but I can say you that the positive voltage is the voltage that is used to bias this op amp or to power of this op amp. So this is positive Vset. Okay, but I will not draw this in this circuit. Okay, now let's write the equation of this. Let's find a formula for this B prime. So if we assume that a current flows through this direction, after reaching at this node, the whole current will go through this way. Why no current flows through the positive terminal? We know that no current flows into the inverting or non-inverting terminal, because the input resistance is very high in op amp. Okay, so if I now write the equation for I can say for this resistor, if I use Ohm's law, I can write EI minus B prime and then divided by R. And again for this resistor, if I use the Ohm's law, I can write V prime minus V naught divided by R. So R cancel, and EI plus V naught is equal to 2 B prime. Then we can say B prime is equal to half EI plus B naught. Okay, now what will I do? I will now decrease the input voltage. Okay, so if you see in the graph, when input voltage was greater than 0, that is in this point, I gain that output voltage is equal to positive Vset, that is it is positive Vset. Then we will get this point. And now if I decrease in input voltage, that is I am now going to the left hand side of this graph. Let's see what happens. So when let's see what happens. So in this case, you see that output voltage is equal to positive Vset. So if I input this plus Vset here, I will get V prime is equal to half EI plus Vset. Okay, so if now after decreasing EI at the moment, I will get that EI is equal to minus Vset, right? And when EI is equal to minus the Vset, from this equation I will get V prime is equal to 0. And if I again decrease that input voltage, then EI will be less than minus Vset and B prime will be less than 0. And if B prime is in this circuit, if B prime is less than 0, I will get V output voltage is equal to minus Vset. Okay, so let's see what happens here. So after decreasing this input voltage, when the input voltage is equal to minus Vset, the output voltage will jumps to the minus Vset voltage, and if I again decrease input voltage, the graph will go leftward. Okay, and now if I write the equation for B prime from this equation, you will see that V naught is equal to minus Vset, right? So V out B prime is equal to EI minus Vset. Okay, so now let's increase EI. So let's increase EI. So now I will increase EI, and when increasing EI when EI is equal to positive Vset. From this equation you will see that V prime is equal to 0. If I again increase input voltage, EI will be greater than Vset, then B prime will be greater than 0. And if B prime is greater than 0, the non-inverting terminal will be greater than inverting terminal voltage, then output voltage will be equal to positive Vset. Okay, let's see this in the graph. Now I am going to the right side of this graph. Okay, as I am increasing EI, and when EI is equal to plus Vset, let's say the point is this, plus Vset, the output voltage will be Vset, right? Then the output voltage will jumps to the Vset. Okay, if I now again decrease EI, the graph will go leftward, and see we have got a hysteresis curve. Okay, so it is the hysteresis curve for this Schmitt trigger circuit. In this case, this point is called upper threshold voltage UT, and this point is called lower threshold voltage. Okay, and this point is called the center voltage. Okay, V center voltage. And how we will get center voltage? We will get center voltage simply summing lower threshold and upper threshold voltage, then dividing by 2. That is, we are taking average of these two voltages, right? And again, it is called a hysteresis graph. Why it is called a hysteresis curve? You will see that when I stood here, I have two voltages, this and this. So which I will get? It depends on the path. If you are decreasing, if you are decreasing the input voltage, you will get this point, and if you are increasing the input voltage, you will get this point. So it's an hysteresis curve. It not only depends on x coordinate, that is, it's not only depends on input voltage, it also depends on how you are increasing, how you are behaving with this input voltage. Are you decreasing EI or increasing EI? Okay, so in the next video we will see that what happens if I change the resistor value R1 and R2, and also if I connect a battery here, and let's say this voltage is equal to B reference voltage. What will happen now? We will see this in the next video. Okay, so thank you.